Okay, so as discussed last time, this week's stream we would like to take a look at how to use external jars inside of MPS and what are common pitfalls there, what can go wrong, what are the different kinds of dependencies that you need, and how would you like to get your dependencies. So is it a good idea to just place the jar somewhere on the file system and have other people commit them into your source code repository? Or is there a better way to do it so that you might be able to automatically manage those dependencies and also to be able to get transitive Java dependencies and stuff like this? So the first thing I would like to do is to take a look what steps you need to take to actually use external jars inside of MPS. So I have the same demo project as we had in the last stream. I added some minor things to be able to show this today, which I didn't want to do on stream because it's quite rather boring, and I'm just showing the results of it. So the toy example that I have built is we would like to use the JAX parser to pass the content of an XML file and just return the containing text of the root element. So it's a rather toy example just to demonstrate how to integrate like an external jar and then use the classes from it. What do you need to do to make sure that you can actually type in the code you would like to type in MPS to get the references right? And what different kinds of dependencies are there inside of MPS to actually access these jar files at runtime, and how are these dependencies propagated, what are pitfalls there, and what to do if you encounter some weird class loading problems, for instance, because the MPS class loaders have some strong opinion about how they should work. And sometimes this doesn't fit what your library expects. Okay, so let's jump into it right away. So what I have here is like a new language. It's also just a toy language, which it contains a single concept. The concept here is also rather simple. It's called XML content, and it's basically there to represent the content of an XML file in the editor. The only property it has is the path to the file, which is a normal string property. It has a very, very basic editor, which is basically the path here as a property, and then a read-only model access, which calls a behavior method get file content to get the actual content of the file. And then we can also take a look at the behavior method here. So the behavior method checks if the path is null, because the Sax builder doesn't like it if you pass in a path that is null, and then constructs a Sax builder with the given path. And don't want to detach, actually, we just need the root element here. So it gets the root element and then gets the inner text from it. So and if there's any exception, it basically returns an empty string and prints the exception to the command line in this case. Okay, so how would I be able to use the Sax builder? Let me remove everything from this method here, which is relevant. So mostly this, and let's remove everything here. Okay, so let me also remove all the dependencies here and here as well, so that we are in a very basic state. Okay. So first of all, we need to get the JDOM jars, which contain the parser. I have already done that. So if we take a look at the file system here, then we should be able to see. Oh. So our project is located here in the MPS build example. And I have a libs folder here. And the libs folder contains the JDM jar, which I manually downloaded for now. Okay, how do we make this accessible inside of MPS? The first thing I did is I created a new solution. So just in the project, create a new solution and named it in this case runtime.lib. And this solution will represent our where we used to load the jar files into MPS so that we can reference the content. How do we do this? So the first thing we need to do, I will also clear everything here. Start from scratch. So the first thing we need to do is we need to make MPS aware of the content of the jar files. So we reset everything to the beginning state. We have an empty solution here, and we go to its properties, module properties in this case. And what we would like to do is we would like to make the content of the jar files accessible inside of MPS. And to do so, the first thing we need to do is we need to build stubs for it so that the content is inside of MPS and you can basically type in code that is referencing it. To do so, in the Commons tab of the solution, simply click the Add Model Root button and then select the Java classes here. So this then asks you for a place where the model root should start, so to say, or what's the path, root path of the model root. In this case, we just leave it as the default, which is in this case runtime.lib. So it's the same folder as the MSD file is contained inside. Wait, no, we don't leave it as default. In this case, what we would like to do is we like to set it to the libraries folder where we have placed the jar files. So we can go to the libs folder here and select it and then press open. And you can also see that in this folder there is already the JDM jar, which is the folder where I've placed the jar files. We click open, and then first of all, nothing yet happens. So you can we just have selected a path from where MPS would look for jar files. And we can now select a single jar file here, or we could select the complete libs folder. So for now, I will select the complete libs folder here and click the sources button. And this actually enables MPS to get the content of this jar files into MPS. And if I now click OK, MPS has created here like this, this entry in the solution for the stubs. And if we open it, we can see that it has created or imported the classes with its content here. So there are all these classes from the jar file are parsed and then represented inside of MPS. And now what we can do is we can actually reference this stuff from other MPS code. So in our case, we go to the behavior of our concept where we would like to read the file content. And we go here and we would like to create a new sex parser. And as usual, as you would do in MPS, so I type sex parser here. Here's sex parser. Obviously, I haven't yet imported the models that we have created. So we should be able to see. Second. Where is it? Oh, here. No, it's not here. Why? Because I have downloaded the wrong jar file, apparently. Yeah. Okay, let's get the right JDM jar. Oh. Let's get this file, place it here, delete the other one. And yeah, then take a look here. MPS, it should now see that there is a new jar file and re-import it. Look. Yeah, so it has now imported JDM2. And now should be able to second. Sex builder, sorry. That was what I was looking for, so we want to build a new sex builder. Like this. And now we select it from our runtime.library, so there are multiple inside of MPS already. Some of them are from my dependencies that I have here, like MPS util from embedded brings their own parser, but I would like to take the one that we have just imported from our specific jar file in the version that we need. This, and then we can say new sex builder, right? This, and we would like to build one for the path. So we pass in the path we have here as a property. Yeah. Store it in a variable. So this is the document that we get back from the parser. And now we just get the root element and get the text from it. And our IO exception is also still out of search scope because we have no dependency on the JDK yet. So what to do there is basically use the intention at missing dependency on reference target. Press enter and F5, and we should be good to go. And here we are still missing the return statement for now. Right, so we want to return this. And this is not a JDM parse exception, but a JDM exception. Okay, so now we catch everything here. And if we now compile this code, we get a compilation error. So what's happening now is that the Java compiler claims that it cannot import JDM2, and that it doesn't know what the document, what a sex builder is, or what a JDM exception is. So if we take a look where these classes are coming from, this is all from our runtime.library thing. And what just happened is that the actual compiler was not able to pick up the jar files when it tried to compile. So on the compiler class path, the jar file is missing. On the meta level of MPS, we now have stubs. We can reference it, And if we take a look at the generated outcome here, for instance, of our behavior aspect, can say so here, preview generated text. And we scroll down here, we can see that this has all worked out, right? So it was able to get the classes to generate the text, but when we then want to execute the compiler on this generated code, the class path for the compiler has no, it doesn't contain anything from the JDOM jar file that we have here. And this is because we only told MPS to build stubs for these for this jar file. That means it will only load the content as an MPS model, but it will not do anything beyond that. So it will not load it onto the class path or make it available to any code that has been generated from within MPS. So what we need to do for this is we need to go to the solution properties of the runtime.lib solution and go to the Java tab here. And in the Java tab, there's two sections. The upper one is for source code. I never really used that because it doesn't look like it's something that works quite well. So the idea here would be that you can reference Java source code. We never do that. Usually we just reference complete jar files, because this just seems much better than using the source code itself. So what we need to do is we need to go to the libraries section here and click the plus button. And this is now already focused into the model root that we use for the model stubs that represent the jar files. And here we need to select the jar files that we want to make available on the class path. So in this case, we only have one. We want to make it available, so we click open. And then MPS asks you what to do with it. So MPS can try creating models for the specified location so that class files can be referenced from MPS models directly, blah, blah, blah. And in this case, we don't do anything here. We just leave it as default and click OK. And now the library file appears down here and we can click OK. And when we now go back to our language that uses the runtime.lib to represent the JDOM jar, we can run the rebuild and eventually it will succeed. Okay. Right. So what this has done now is that MPS, whenever the runtime.lib solution is used, it will also put the jar file, in this case only the JDOM jar file, on the class path and make it available for the compiler. Or at runtime, when somebody is using it, we also need to make sure that the jar file is available and that you can call into the classes that are in there. So let's try this out. So I have a sandbox solution here. It contains a single model. And it contains one of these XML content roots, but I will just delete that one and create it from scratch. So what we want to do is we want to create a new root node. In this case, the XML content root node. And we need to give it a path. And since I'm lazy, I have already created an XML file in the repository that contains some dummy data. So just have a quick look at that file. So here in the repository root, there is a folder test data, and it contains a single XML file, data.xml, and it only has a single root element. So let me copy the path. Paste it here into MPS. And this data/data.xml. And once the path is valid, we can see that the content is read into MPS. And the parser gets the file content. So what we have done now is successfully used an external jar file to parse the XML file, just extract the root elements content and display it inside of an MPS concept. So the jar file is now available in MPS. The classes are loaded. You can basically interact with them as you like. And now the next thing would be to put this into the build, right? So we can now use it inside of MPS, but this is only the development side of it. So at some point we also want to build like something that we can distribute to our users. And this is typically done with the CI build, which we took a look at last time. And there we also need to make sure that that the content of the jar files is available there. So what do we need to do for that? So let me go to our build script, which we also created last time. It's this one here. And we can already see that it is quite some errors here. I will remove everything from here and just create the minimum example that we would like to have. So we have our language sandbox B that only contains our concept for displaying the XML content. So let's reference this one first. Let's encode languages, language B. And as we have seen last time, we select the MPL file and then load the information from disk. And immediately we get an error. And if we take a look here, the error is a dependency on module not visible from current build script. And then the ID and the name, in this case, it's runtime.lib. So we also need to add our solution that we use to the build script. So this here. This is also in the project root code, solutions, and then we select our runtime.lib solution and the MSD file. And as usually, we can load the information with the intention. And now we still get the error here because MPS has not extracted this dependency for us automatically. So what we can do to do this is we just select the complete group with the cursor, press Alt Enter, and then invoke the reload modules from disk intention like this. And now MPS has stored the information, or the build script has been updated to incorporate this dependency here. So the runtime.lib is now part of the dependency section down here. Okay, so good so far. If we now take a look at the upper part here, we have a plugin defined for our language, which is the normal way of making your language available inside of MPS for others. And now we would like to put this plugin into the default layout section of our build script. And the default layout section describes what is the actual artifact that we are generating for out of this particular build. So in this case, I just select plugin, which allows me to reference the example plugin that is defined on top, like this. And now we could actually try to generate this. And if we now do this, we get some errors. Check where the errors are. I think it's from the tests. So let me. Let me remove this completely for now. We will add the tests back later again. Okay. So let's rebuild it. And now we get an error message when we try to generate our ARN script out of the build script description from inside of MPS. And what's the error that we get? It claims that it cannot build a relative path to the JDM jar that we are using as a dependency. So if we click here, we get into some intermediate model, which does not really help us, right? But if we go to the input here, which is the second part of the error message, we can actually see that it's somehow related to our runtime.lib solution, and that there is here a jar dependency on project.home/libs/jdem2.0.6 jar. And it claims that it cannot build a path to this jar file during the build. And what MPS actually means is that the jar file is missing in your layout. So the error message here isn't the best one actually, because it doesn't tell you anything about where to fix it. It only tells you that something is missing. In this case, that it does not know how to handle this jar file. And what you need to do is the plugin that contains your runtime.library solution, here in this case the example plugin, it needs to distribute the jar files so that they are available to the user of your plugin. And how can we do this? So the easiest, the normal way to do this is that you create a new folder inside of your plugin. Usually it's called lib. You can choose a different name. But in some MPS versions, it might actually not work, because some older versions of MPS have some implicit assumptions where they can load jars from. So I would strongly suggest to keep the name to lib. To avoid any other problems. And now we have this folder that we create in our plugin, and we still need to fill in the content, right? So the easiest way is to say we want to add files from a given location into this libs folder. So we select files from the code completion menu. And now we want to build a path to the libs, which are located in the libs directory directly in the project home path. And we can just select it like this, because it will recursively copy the complete folder if you use files from. You could also use file here, and then we could select a single jar file. So in this case, libs/ and then we could also just place a single jar file in there, often using the files from is a much more safe way to do it, because you cannot accidentally forget a jar file and fail the build through that. So let's remove the upper part and add this here, and only have it copy the complete folder. And now if we rebuild, the rebuild will succeed, because now the logic during the build has figured out that the jar file that is required by the runtime.lib solution is actually part of the things that you distribute, and that at runtime there's no risk of having the jar file not being loaded correctly. So this is one common pitfall that you will often encounter when you start using jar files from within MPS, that you most probably miss to put them into the default layout section, and you will not really get the you will encounter the error that we have just seen. This is why I would really suggest putting your jar files into a defined location, and then include the complete location. So even if you add new jar files, you automatically include all of them here. I will show you later how we can what is something that you also need to take care of when you have transitive dependencies, etc. So especially then it's not so straightforward to use or to rely on including single files. You definitely want to include the complete folder then, because you don't want to add each and every single jar file into the build script every time some of the downstream dependencies might change. Upstream dependencies might change. Okay. So this would now allow us to build this from the command line. Then we get like a distribution out of it that allows us to distribute our plugin with the included jar file. But now let's imagine we have a somewhat more complex setup. So this was the case. We had one jar file. It's self-contained. It has no external dependencies, apart from the JDK, of course, but it has no third-party dependencies that we would need to package, make sure that they are available at runtime as well. So let's have a more a bigger example, for instance. So one example here is that I have prepared is that I have a small Java library. Let me actually open that one. That example is also part of the same repository. Second, source, build, and then it's not in code languages or solutions. There's also a code Java folder here. So let me open it in IntelliJ and import the Gradle project here. So net in a new window, import changes. That now takes a bit. So let's wait until IntelliJ has finished loading the project. Okay. So what's the project about? So the project here has a single class file. So there's a single Java class in here. And this Java class uses the this one now. 1 second. I think we need to set up the project. SDK, I think it's still here. So this is Java 1.8, so we should set it to the correct Java level. Right. Okay. So what we have here is a single class, which is a helper class, which uses the Java money API or library to do some calculations, and in the end round the get back the result with 2 decimal numbers and do rounding half up. And if we take a look at the Gradle file, we have only specified a dependency on Java money moneta. And if we take a look at its dependencies, we should be able to see, is there a nicer view of getting the dependencies here? Wait, yeah, we can just show it in Gradle. Second, so code Java, and if we now ask Gradle new dependencies, so if we scroll up to the runtime dependencies, if we take a look at the dependencies that we have defined here is we only depend on the Moneta core artifact from the Java Money API. But if we take a look at its dependencies, it brings in another dependency, which is the JavaX Money API jar and the JavaX Annotations API. So in order to be able to use the class that we have defined here, we would also need these jar files to be available. So if we would do everything manually, we could now compile the jar file here, copy the jar file at the right location, in this case our libs folder, then make sure we copy all of the dependencies that we also need into that folder so that we can distribute them, because without the Java Money API, our helper class is useless, because at runtime, the classes here, currency unit, money, etc., they would not be available. So we need to make sure that they are also available at runtime. Okay. But there's an easier way to manage all of this. So the first thing is I will publish the artifact here into a Maven repository, in this case Maven local. So publish that. Okay. So this has now put the jar file, including a POM file, etc., into my local Maven repository, and we could download it from there. And since the POM file that Gradle has generated for us also contains the dependency information, so in this case that we need the Java Money API, we can actually make use of this information and download all of the transitive dependencies automatically. So how can we do this? So let's close the Java project for now, because this is no longer relevant. And go back to our MPS build project. So here is our build script. And what I have done here is I have created a new configuration. It's called libs in this case. And then I have declared a dependency. I will leave JDOM in here and just remove it for now. And I have declared a dependency for this configuration, which is my Java example library here. And now, if we go down a bit here, there's a task called resolve libs. And this task is basically responsible for looking into the libs configuration with the declared dependencies and then resolving them and copy them into my libs folder. So if we execute this task, so from the Gradle perspective, it's quite simple. The first thing we do is we actually clean the libs directory so that we do not have old artifacts in there. And then what we say here is that the copy task, resolve libs, should copy from the configuration libs. Once it has been resolved, this is why we call resolve on it, into the libs directory here. Okay, so if we run the task, this, and we take a look into the libs folder here, we can now see that it has downloaded the Java libs jar and the dependencies that we have. So since Java lib uses the Moneta core, and Moneta core uses Money API and Annotations API, we have downloaded all of these transitive dependencies to the directory and placed the jar files there. Okay, so this way you can easily manage those external dependencies with Gradle, get all the benefits from the dependency resolution and the updating. So if we would change Java lib to use other other dependencies as well, we would automatically just download the new version, and Gradle will take care of getting the dependencies for us, like it would do with any normal Java project where you use Gradle for as well, except for the case that we do not pass this directly to the Java compiler, but we place them in a predefined location, in this case the libs folder here, and then make them available inside of MPS. So how do we do that later? So it's basically the same as we did it before. So one thing. So if we now take a look here at the runtime.lib, we can see that there is already new stuff in there. So our helper class with the calculate method that we have defined here, this is actually now available. How did this automatically happen? So the thing that MPS did behind the scenes is, as a module root from where it should load all jar files, we have selected the libs folder, and MPS will listen for changes to the folder and then automatically update the stubs. So in this case, it has found the Java lib, the annotations, moneta, etc., and imported all of this inside of MPS and made it available as stubs. This is not always the behavior that you want. So in our case, we don't really care about the Java money stuff and the JavaX annotations. So what I will do here is I will unselect the sources on the complete folder. And the only thing I really care about for now is the Java lib, because this is the dependency that we would like to call into. And we don't want to actually expose the fact that there is the underlying Moneta core and Money API jars, that they are actually used, because we do not want to expose this to the people who are using the Java library here. So you can imagine the Java library being some of your Java libraries or execution environments or tools that you would usually use from the generated source code. But you just want to have this API available inside of MPS so that you can generate code against it or directly call it from, for instance, an interpreter. Or you can also use any kind of jar where you would like to use the functionality from, like an HTTP client or something, because you want to do HTTP requests from within MPS or something like this. So what I will do now is I will only select the Java lib jar here and then click the sources buttons. And the result is that on the left side here, the sources is no longer pointing to a complete folder, but it's pointing to our Java lib 1.0 jar file in this case. If I press OK, MPS will now re-import this, hopefully. In this case it does not, so let me close the project and reopen it. So sometimes these stubs are not, especially if you remove them, they are sometimes not refreshing immediately. So this is why I just closed the project and reopened it. So this causes MPS to reload the project here. Another thing you can do is to click the tools reload all classes button. This also invalidates the stubs. Okay, so now our stubs only contain the helper class and not any of the dependencies of the helper class. Oops. And now we would like to use this helper. So how can we do this? So let me introduce a new concept here. We will just call it add with rounding. This, we make it an expression. Just so that we can put it in an expression context. It doesn't really matter for our case now, but we could also just make it a base concept and then we can actually do that as well. So let's make it base concept and not introduce any external dependencies here. Make it routable. and give it some alias. Add with rounding. Okay. And we just give it some children. So I'll call them parts. And these parts are number literals. So they are simple numbers that the user can type, any arbitrary number of them, and we will try to sum them up and return the rounded result. So in this case, we select the number literal from the code completion menu here, and we don't make it 0 to 1, we make it 0 to n, because we would like to have the user to be able to define an arbitrary amount of numbers he would like to add. Okay, so let's create a very simple editor for it. So concept editor, just a horizontal collection. In this case, horizontal collection. Add with rounding. Okay. And we would like to display the parts and then a closing bracket at the end, just to make sure to indicate where the parts end. And what we also would like to do is we would like to give this a separator, because otherwise it looks ugly. So here, just select comma as a separator. Okay. I now build this. Okay. And we can now go, for instance, to the unit tests that we have here. This is test, that's import code. Here's our test. Let's go here, remove this. Okay, so now what I would still like to do is I would like to have a class or some Java code where I can pass in the add with rounding instance and get the result back. This could either be a behavior method or just a Java class that we use to do this. And I'm opting for using a Java class and not introducing this directly in the behavior. But there's no special reason for this. So we can also write the same code inside of the behavior aspect, and it wouldn't be different in any way from what we are doing here in the Java class. So let me call the class interpreter, because it's interpreting the content of the concept. Give it a public method that returns a big decimal. Big decimal in this case because the underlying Java money API is using big decimals as well. And let's call this interpret. And the node that we want to work on is the add with rounding. Add. And in this case, we still need to make the method static. We don't want to have it as an instance method. Let's go to add, and then we have the individual parts. And now we want to, so if we now take a look at the Java class here, this the API here takes a list of big decimals, adds them, and then returns the result as a big decimal. So what we need to do is we need to convert these numbers into big decimals. So you can just use a select operation here and say big decimal from value of constructor call string new big decimal string in this case it, and a number literal. So if we go to the definition here of the parts, those are number literals, and if we follow the reference from the number literals, we can see that the value here is stored as a property, and it's a string. What we could also check is there another way to get the information here. Yeah, there's get string value, which is defined for every primitive literal. So, but let's just use the value directly here. Take the value and create big decimals out of it. We now assign this here. We have a sequence of big decimals that we created out of the individual values. These are the parts. And now what we can do is we can go to our helper here, which we need to press Ctrl R to solve. There are quite some helpers here, so let me select the right one. So this is here, the one from our runtime.lib solution, which is a Java stub. Oh, now the helper should be available. Yes. So here we want to do static access and call the calculate method and pass in our parts. No, it's now complaining. Our sequence is not a list, so let's just convert the list here. Okay. Since MPS has this implicit logic, wait, we return this explicitly. Yes, so this is also one neat trick, which I learned quite late. MPS is when you have an expression like this, which is in this case just an expression statement, and you want to convert it to a return statement, one thing you can do is you can select the expression, press Command X to cut it, then remove the expression statement, type return, space, and then paste the expression into it. Apparently I didn't copy correct. Oh, this. And you can already see that it's quite cumbersome to do. But there's one neat trick that you can do, and that's going to the expression statement, selecting it completely. So the easiest way to do this is to go to the very end, press Shift and down, which selects the complete AST node, and then just type over it and type return. Press Shift to the left, so, instead of down, and then just type return. And what now happens is that MPS converts your expression statement into a return statement where the returned part is the expression where you have typed your return over. So in this case, we now have a return statement for returning the result of the helper calculation. Of course, MPS has this implicit notion that you have an expression, so it's at the very last so if you have an expression statement as the very last statement of your method, then this is implicitly the return statement, so it's a bit like Groovy. But I don't always like this, so I'm often making explicit returns instead of having these implicit expression statement as returns. Okay. So now we have a helper class where we can pass in any instance of our add with rounding. It takes care of converting the values from the model representation, in this case the number literals, into big decimals, then calls the helper, which does the actual calculation and returns the result. So let's try this out. So in a test, I'm just using a normal node test here. So let me create a test node. add with from our concept, add with rounding, and let's add some number literals. 1, 2, 3, for instance. This. Okay, now I would like to be able to pass this into the interpreting helper. So how to do this? So the test DSL from MPS has a way to label parts of the model that you have described here. So this is like introducing a variable that references to this part of the model. You can either do this on the very top level here, so selecting the complete node that you defined for the test. So go here, say add test label annotation, and then it's the complete nodes or program of your DSL that you have defined here. But you can also do this on a more granular level. So we could actually, you can also do this on individual expressions here, for instance. So we could say this is the 3 expressions. For us, this is not really relevant at the moment and not something we need now, but it's often handy if you have like a complex model that you would like to construct. And then you would like to work with individual parts of these models in the test code below. So how you do that is after you have attached your test label. I want to attach a label, not a test annotation. So let's call it add. And now let's create a test method here. So simple test method test that works correct, or that operating. And now if we press Ctrl space down here, there's a new variable available in the code completion menu. And this is the add variable here. And this variable contains the content or the model elements that we have annotated up here. So now we have the, we can actually reference this and use it as in normal code. So what we want to do here is we want to use our interpreter. Yeah. And call the interpret method and pass in the add with rounding that we have defined up here. So we also get full type system support. So if we check the type of this variable, we can see that it's of type node, and the concept of the node is our add with rounding concept. It would also allow us to do all kind of other stuff with it, like accessing properties of it, calling behavior methods on it, etc. But this is not what we would like to do now. So currently we just pass down the instance here and expect back a result. So here we now have a result. And if we add 1, 2, and 3 together, this should actually result in 6. So let's write our assertion here, big decimal from of 6 equals result. So like this. I'm not using any fancy assertion framework here, just using a normal Java assert statement. Of course, you can use all kind of MPS magic, or MPS extensions to the test language here, like assert equals, assert false, same, matching, and so on, all the things that MPS gives you, or you just use Hemcrest or whatever other assertion framework that you are used to when using normal JUnit code. So, okay. So now let's build our language. And we can already see that we have a problem here. And so what we see here is that our helper is not available to the Java compiler. So what's missing? As we had in the beginning, we need to define in the Java libraries of our runtime lib, in the Java part here, in the Java tab, in the libraries, we need to define which jars are available to the class path. So in this case, it's java.lib or Java lib, which contains the helper function. We want to make sure that this is available at runtime for the compiler, so that it can compile our code that is using the stubs that we have built here. So if we go back to our language, the compilation eventually succeeded. Okay. Now let's go back to our test. So we have our test method here. We have our assertion, etc. And now let's try it out. So let's run it in MPS. So just right click on my test, select run my test. And now MPS will generate the test, actually run it, and close the inspector so that we can see what happened is the test failed. So what has happened? Let me get the stack trace out so that we can read it better into a text editor. 1 second. Here. This, paste it here, and increase the font size quite a bit. So what we can see is that it tried to execute our test and tried to initialize the test. And what we get here is a no class def found exception. So when it tried to initialize the helper class, it wasn't able to find the currency context builder. So the currency context builder, if we go back to our Java code in the helper class, we use this currency context builder to get a euro currency and use euros as the currency to do our calculations with. And now we have loaded our Java lib jar, right? It's available for the compiler, so the compiler can observe the helper class with the evaluate method here, calculate method here. And for the compilation of our interpreter class, because this is the only thing that we use here, we just use helper and call calculate on it. This is all we need. But at runtime, when we now try to execute the actual calculation, starting from the interpret class, then dispatching into the helper, the dependencies of our helper are not available to the class path. So they are not loaded because MPS has no idea about them yet. So how can we fix this? The first thing we need to do is we need to go here to the Java tab of our runtime lib solution again. And instead of only specifying the Java library jar, we want to specify everything that we need. So also the other 3 jar files in this case. So the money API, Moneta, and the annotations API. Okay, so let's open them as well. Just click OK here, and then MPS also recognizes these jar files here as dependencies. So all that you define in this Java tab of your solution, this is what actually happens at runtime, so or compile time. So everything that is passed, for instance, generation or the actual model perspective from MPS. So as soon as you leave the MPS world and you have generated text code, text files out of your MPS models that represent Java code, when you have your Java code and you want to compile it, or executed, this is what actually defines which additional libraries MPS will load for you. And the first part here, the Java classes model root for in this case, is only what is available inside of MPS. So it builds like these stubs for you so that you can reference the content. So this is two things you really need to keep in mind and need to understand, that there is the stubs part here, which is only the configuration of which parts MPS makes available to you as model elements inside of MPS, and that is the Java tab here, which represents the actual runtime perspective of your solution or languages. So you can also define this on languages. Okay, so let's hit OK. And let's try again. So let's go back to our test and run it again. And if we look back here, we can now see that at least the test was executed. But we still have some errors here. So in our test here, we have an assertion error. And this is most probably because we round to 2 digits here in the end, or to a precision of 2. So let me change the assertion. And it still fails. Okay, let's do this in a different way. So what's the actual values here? So we have the assertion error. If we click here, wait, let me unselect this. So if we click here on these line numbers, MPS will automatically translate these Java line numbers into model elements so that we can see that this assertion here failed. But to get better results here, to actually see what's going on, I'm using assert equals here, which now allows us to get some more insights about what went wrong. So we would like to say that the result is equal to 6.00. We run it. Now the test failed because okay. 6 gets set scale 2, so that they are both on the same scaling here. Okay. So now you can see that the other jars are also loaded. So we can now call into our interpret here and then go to the helper, call this function, and then inside of the function, all of our dependencies, the currency unit, etc., are available. Even if here in MPS they are not available, so we haven't built any stubs for these classes. So MPS will still consider them out of scope here. We can fix this. In this case, MPS shows us also private fields, which causes us to see that we are missing something. Yeah, in this case, it's usually up to the developer if you really want to import all of your dependencies here or not. Because usually you just want to import the dependencies that you would need for your public API service. We can actually do this here and set MPS so that it would also generate stubs for our currency unit, but I won't do this now. Okay, so let's take one more look here. Okay. Okay. So one thing that MPS also supports is that a language can have runtime dependencies or runtime solution. So what is this? So in many cases, you want to make sure that when a given language is loaded, that also a solution is loaded along with it, so that you can safely access the content of that solution. So, for instance, I remove this. Also now rebuild this. This is not so much a problem within MPS when you are in the development mode, right? So when you are within the IDE and you are developing your languages, this is usually something that is not really required because MPS will simply load everything and make everything available to you. But when you want to run the test from the command line, or you would like to distribute your plugins, MPS needs to know what is required to load when it encounters your language. So one single example here that we can do is, so if we go back to our tests here and we leave everything as it is right now. So since I have added new jar files, MPS, so the build script here, do it, now complains that the new jar files that we have defined here are not part of the build script. So we can also fix this by reloading these informations from disk. And then you can see that in the dependencies section of your build script, our new jar files show up. Okay. So let me remove language B here and add our language A, where we have just added the concept again. So project home, code, language. What's going on here? Project home, not project home is defined. Okay. Let me just regenerate this to get code completion working so that all the folders have been created. Okay, so let's add a new language. Project home, code, languages, language A. This, okay, reload this from disk. We still have some dependencies here that we don't really require, I guess. Yeah. So let's optimize them. Let's remove them here. Optimize imports. Okay. Okay, so there were still some unused dependencies here on our language. And MPS has a functionality. So first of all, when you check in the dependencies tab of your language or solution, MPS will gray out any unused dependencies. So if you declare a dependency on something, but you don't actually use any content of it, it will gray them out here for you. So this is already an indicator that you have dependencies that are no longer required. But MPS also allows you to automatically remove them. So you can either do this on a model level or on a complete solution. So on both, you can basically click the Optimize Imports button. And on a model, it will look into your imported models and remove all the imported models where you are not using anything from. And if you do this on a solution or on a language, it will look into all the models, remove them there as well, but also remove those dependencies on the module level. So what I just did is I triggered the optimize imports for this language, and obviously there's nothing to optimize anymore because I just executed it. It removed the unused dependencies for me. So the unused dependencies in this case were just some of the import code here, which we didn't use. And I think there was still a dependency between those two languages from something I tried out earlier today. And we have now removed this. And now also our error here in the build script is gone because it was complaining that there is a dependency between the language A and language B. And we did not include language B in this case. But we don't really want to include language B for the sake of this example now. Okay. So this is also now where this include from a complete folder comes into the perspective. Because as you can see now, we have, from the first look, we only have a single dependency. But since we have transitive dependencies and, well, the dependency that we use has some other additional dependencies, and those have dependencies as well, etc. So we have quite some transitive dependencies here. In this case, it's already 4 jar files, if I'm not mistaken. Yeah, so we have our normal Java lib, that is our direct dependency, and then the 3 transitive dependency jars. And if you want to really maintain this with individual jar files here, this can be quite a pain. So this is why I would really suggest using the files from and specify a folder instead of individual jar files here. Okay, so we have our plugin here. We have also our language and our runtime solution here. We package the plugin, and we also include our jar files that we depend on into the plugin that we want to distribute. Let's execute this and rebuild the solution. So now we would have regenerated those build scripts. But what I would like to do is now we have this test here, right? That we just executed within the IDE, where everything was fine. But now let's add these tests to the command line. So first thing here is we add the test solution to the test build script. So I'm in the examples.test build script here, which was empty before. There's only a skeleton part in here, which I left in there. But in the previous stream, we also explained all the individual settings that you can choose here. So I will just re-add our test solution. Like this. Test language A, L, and reload it. Okay, then let's just add it quickly to the layout and do the test modules configuration. Sample tests. And I did the same mistake as last time, which is I forgot to include the tests here. So we need to set the content of this solution to be what we are doing on the what we want to include here for the solution in this case. And now it should show up here as well. Yes. And now we have a test configuration here, which allows us to execute the tests that are defined there. Yeah, I know that it is quite advanced stuff at the moment. I will start a series on doing some more basic stuff next week. So, but this is basically what I'm doing now is what some others who are already familiar with the tool had quite a lot of questions about. So I'm showing that. So, but starting next week, I'm going to start a series where we really start from scratch with very basic things like setting up a project, defining your own language step by step over multiple iterations, so that it's also more beginner friendly. Yeah, maybe you would like to take a look at that then. Okay, so let me rebuild this. It's missing. See here. So the input is here. Yes, I will upload the videos. They are available on Twitch for 60 days, and afterwards I will put them on YouTube as well. There's also a Slack instance actually where we where you could also go, and where there are people from JetBrains and others who use the tool who are pretty friendly to help newcomers to get started. I'm also there, so if you have any questions, you can also stop by there and just ask questions how to get started. I will also announce the streams there as well. So for some reason, MPS thinks we have a dependency here on B, and I think I know why. And this is now one of the quirks of MPS. Oh no, I'm not working for JetBrains. We know quite some people from there, but MPS is open source tooling and we are just using it. So I'm using it for now, I think 6 or 7 years almost. Yeah, it's mainly my day job to work with this and to build programming languages for other people. But I'm not working at JetBrains. Let's check one thing. I think this is one of the bugs in MPS. So the problem is here, the build script generator now complains that we would have that we have a unsatisfied dependency. So the generator thinks we depend on language B, but we actually don't. And I think this is one pretty annoying bug in MPS. And this is part of how MPS internally stores dependencies and versions. Let's take a look here. So I think the problem is that we still have a dependency somewhere down here. Nope. Or do we have one here? Search for .b. Nope. On this Slack instance, there are also quite some people from JetBrains. Most of them are developing the tool as well, or some of them are also using it. But there's also quite a large community there of people who are or large, at least for DSL tooling, larger community there, who are applying the tool from various places of the world, and they are all happy to help. But currently I have no idea why my MPS complains that there is a dependency here. 1 second. So let me go. Okay. I think here is still a dependency on language B, which we can remove. Yeah, it's actually unused. So we can also run optimize imports here. This, remove that. And now our generator should work. Yeah. Yeah, this is quite a quirk of the build language, that its error messages are not always as you would like to have them, and it takes quite some experience to know where to look when a certain error is printed. So yeah, it's a long-standing issue. It's also one of the oldest parts of MPS. This is most probably why it hasn't really got an overhaul in the past. So okay, what we have now is an ARNT file that would allow us to run the tests. And in the last stream, we have actually built the Gradle wrapper to execute them. So let's do this again from the same way as we've built it last time. So let's run Gradle. The task was called run tests, if I remember correctly. Oh, Gradle wrapper. Let's see if it's the right one. Yeah, seems to be the right one. Okay, so let's wait until the build from the command line is finished. And I hope in this case it's failing, because I want to show something that sometimes happens with if you don't set your dependencies correctly. But it's not always easy to reproduce. Let's take a look. So now it's running the tests. And let's see. Okay, what has happened now? Oh, this is not related. Okay, now example project was opened, and hopefully, yes. Okay. Oh. Okay, it was successful in this case. Yeah, or no, assertion has not failed. At the test results file. So did they fail or not? No, we have no failures. Okay, so it worked. Okay, so what sometimes can happen is that in the settings that we have right now is that we have a solution here, and that the solution is using this runtime libraries, that the runtime libraries are not loaded correctly. And the way to express that MPS should always load the solution together with the language is to associate it as a runtime solution here. So I'm just adding the runtime.lib here as a runtime solution. And I think now it will have no effect because our tests were still successful. But if we take a look at the build script now, we can see that the build script now complains that there is something missing here. So in this case, it complains that the runtime solution is not extracted into the build script. And if we reload this, down here in the inspector, MPS shows that there is a new runtime dependency, and that the runtime.lib is now a dependency that it must load in all cases when also loading this language. This is sometimes required, especially when you generate code. So imagine our runtime.lib class, so the helper class from there, is not only used within our interpreter, but it would be used as generated in the generated code, right? So in cases where we could write our add with rounding somewhere into a program, and we would like to generate code out of that, we need to make sure that when we are generating this code, our runtime.library is also loaded correctly. And this is this runtime solution association is one way of expressing this stronger relationship between your code that you have in a solution and the code that you have in your language. So this also allows you, in that case, to use the code in the or the classes in the actual generator. But we will take a look at generators and stuff like that, not today, because this is way too much. So what I have had planned for today, so taking a look at how we can use Java files in MPS and how we can make them part of the build. I think I'm through with that. There's one more thing, which is also hard to reproduce, but sometimes happens. And that is, and show the actual documentation we have written for it. So sometimes it happens that you get weird class loading exceptions, and they are really hard to understand. So sometimes you get a class loading exception or class cast exceptions that classes are not of the correct version, or that like a JDOM document is not a JDOM document. And this usually happens when a class is loaded twice, but under different class loaders. This can happen within MPS in certain combinations. So for instance, the JDOM, for instance, MPS ships its own version of JDOM. But you might want to use a specific other version of JDOM in your application. And if you add the JDOM jar to your runtime libraries, you might end up with MPS loading the wrong class for your or of JDM. So one part of your program might observe the actual version that you include as a jar file, and the other one might see some version that has already been loaded from within MPS. And this usually happens because MPS has a quite complex class loader structure behind the scenes to make sure that you can change languages at runtime, that you can reload them, and all of these kind of things. So there's a custom hierarchy of class loaders involved. They don't always like to load resources correctly. So if we take a look back here at the command line, for instance, what you can see here is warnings that in this case, the money API couldn't load its default settings correctly and defaulted back to something. And this is the case because inside of the Moneta core jar, we have a properties file that is the default configuration for the Java money subsystem. And you can actually override this by putting your own Java money properties in your jar file. But the MPS class loaders that are now involved, they do not like to load resource files from a jar. So this is one thing that one also needs to keep in mind, that the MPS class loaders are quite reluctant to loading anything than classes. So accessing property files or resource files from within MPS class loaders can also be quite a pain. We can do an extra episode on how to work around this, but there we need to do some much more work to get this working. So back to the problem with the class loading. So when you ever encounter such class loading problems, so that you see JDOM document is not a JDOM document or something, what usually helps here is temporarily replacing the context class loader. So on the MPS wiki here, there is a section about class loading issues. It also describes how to use the jars, etc. in MPS, what we have done today. But it also describes what to do in this case. So what you can do here is you can get the current class loader from your own class, and set this as a context class loader. And any library will usually respect the context class loader on the current thread. So this works around this weird limitation of MPS that it sometimes gives you classes that have been loaded by some other module because you are loading the same jar 2 times in the same application. It works around it. It's what is really important is to set the context class loader back to the value before. So the sex parser is usually a prime example where you get class loading problems when parsing a document, because JDOM is loaded by MPS already, and then it's 2 times in the same application. And depending on the path that you take to the through the class loaders of MPS, you might end up with classes being picked up from different jar files, and this works around it. Yeah, it's I cannot really explain in which cases it reliably happens. There are some parts in our open source world around the MPS platform and extensions that have to do it, and you can get an idea about it when it might be required. So let me search for all these here. So for instance here, plant UML, we have an integration for that as well. And when it tries to load its own documents, it's also using JDOM2 behind the scenes. And we had quite some problems in scenarios where we wanted to load SVG files generated with plant UML into the canvas here, where we had this weird class casting problems, and this works around it here in this case. Okay. So when you have really weird problems with class loading, then try to do this. It might help, but it's usually the choice that you only take when you have no other way of working around this. There have been quite some improvements in the recent versions of MPS, but it might still be a problem. So it's something to keep in the back of your mind, but not something you should apply and sprinkle through all the code base. And it's usually only happening with JDEM because it's the most prominent thing that MPS already loads. Yeah, but if you see class cast exceptions with JDEM, try this workaround. It usually works. Yeah, for today, this is all I had prepared, I think. So as usual, you can find the code on GitHub here. It's in the same state as it was as the beginning of the stream, and I will also commit the results and push them to GitHub in a minute. Other than that, I've planned to start a more beginner-friendly series about how to build your very own basic language that supports some basic expressions, and then we step by step add more features to the language, like interpreters, code generators, type system, etc. And I'm starting with that next Thursday, so the same time, 6 o'clock in the evening, European time. I'm starting. I think it will be quite a long series, so I might change the schedule to do it at least twice a week. So otherwise, we won't be finished by mid next year. And I also plan to do it in like 2 to 3 hours increments. So I will set up a GitHub repository for it, where you can also open issues with ideas or send pull requests to, and we take a look at what you have implemented there together. You can also always ask in the chat any questions that you have, anything that you didn't understand. I know that the current topics were quite advanced, and for beginners maybe not really easy to understand or to even follow. Yeah, so that's it for today, I think. Have a good evening. And yeah, as I mentioned earlier, also take a look at our Slack instance and sign up there. There's a dedicated channel for these streams where we can discuss, you can give feedback, and I will try to incorporate it. So until next time, bye.